Understanding identifiers. In this nugget, we're going to learn what identifiers are in MySQL and what the syntax rules are that govern identifier usage. We'll then turn to using qualified object names. Perhaps what I've just described, these two bullet points, come out of left field and you're thinking, Tim, did you just speak to me in Mandarin Chinese? Or if you speak Mandarin, Tim, did you just speak to me in Russian? Or if you speak Russian, Tim, did you just speak to me in Space Alien? However, selective disclosure tells you that, hang on to your hats, by the end of this nugget, you'll understand all about identifiers, syntax, and qualified object names. Let's get to work. Friends, in relational database theory, and in MySQL in particular, an identifier is simply how we identify an object in a MySQL database. Actually, one good example of an identifier would be a MySQL database. For instance, the World Sample Database or the Sequila Sample Database. Another identifier or an object identifier would be a table within a database. The way we use identifiers is by naming them in MySQL. And there's two ways to refer to identifiers or objects, either in an unquoted fashion or quoted. Now, when we're unquoting identifiers, we're just referring to them. For instance, we may run select star from world.city. Now, we're going to talk about qualified identifier names or qualified object names shortly. But here, we're saying we want to select star, all rows, all columns, from the city table in the world database. And you notice that when we're using unquoted syntax, we're not quoting or explicitly demarcating those object names. And in most cases in MySQL, that is to say, out of the box, MySQL is set to a fairly permissive mode to where you do not need to explicitly quote your identifiers. Your object names, that is to say, your database names, your table names, your column names, your stored procedure names, your function names, all of those are good examples of objects that are referred to using these identifier or handle names. Can take just your standard alphanumeric names. In other words, you can name your database A something, B something, C something. You can even start them off with a letter if you want to. In other words, an identifier can contain all alphanumeric characters. They even can contain underscore, $, or any traditional non-alphanumeric character. However, an identifier cannot consist entirely of digits. You're going to get an error by the MySQL parser if you were to try to create a table called, let's say, 321. Another thing you want to keep in mind when you're referring to identifiers and creating objects in MySQL database is that you want to avoid ambiguity. And we'll go into some detail on this in the upcoming demo, but you don't want to create column names or table names that use reserved keywords. For instance, you probably wouldn't want to create a column name called insert. You can, and I'll show you ways around that. But by default, if you tried to create a column using a reserved keyword, in this case insert is a reserved keyword that's part of the structured query language, the MySQL parser is going to bark at you because it's going to be unable to tell whether you're trying to use the insert statement in SQL or if you're referring to an identifier object. This is where quoted syntax comes in handy. Another aspect of ambiguity is if you're creating an object, and again, an identifier object can be a column in a table, a stored procedure, a function, anything like that, to where it might have some other meaning in another context. Look here. 0x1 might be a nifty column name, but it also is traditional syntax for hexadecimal notation, traditionally 1 in hex. So as a database designer, you want to be careful how you're using your object names and your identifiers so that they don't collide with other usages that your users and your fellow DBAs and database administrators might use. Now then, let's look at the other side of the equation. When are cases where we would want to explicitly quote our identifiers? First of all, how do we quote identifiers? Out of the box in MySQL, the default setting when we quote identifiers is to use the backtick character. Now, the backtick character is separate and distinct from the single quote. Please understand that. If you're wondering where the backtick is on your keyboard, find the tab key on the left-hand side of your keyboard and look directly above tab, and there you'll see the backtick. This is what MySQL uses, not the single parentheses, but the backtick. We're going to see that the single parentheses is used in a little, or the single quote, I should say, not single parentheses, sorry about that. The single quotation mark, or as Brits call the tick mark, is used for a different purpose. So again, the backtick is used to quote objects in MySQL. If you are more old school and you're used to using, say, Oracle or other SQL systems that subscribe in a more orthodox fashion to ANSI ISO SQL, you can set your SQL mode to support ANSI quotes, and this would allow you to use double quotes. You can also, in Microsoft SQL Server, do this as well. Use double quotes for your identifiers if you'd prefer not to do backticks. Now remember, backticking is optional under most circumstances. Really, the only case where you would need to use backticks is in a case where you think MySQL parser might get confused in the identifier or the object that you want to use in your select statement or in your create statement, whatever. Now, as I said, the single quote character is used for a string literal. And a string literal is, for instance, where you just want to mark an alphanumeric string explicitly in a select statement or in some other procedure that you're doing in MySQL. Identifier case sensitivity. The issue of case sensitivity is important here simply by virtue of the fact that MySQL is a multi-platform RDBMS. Those of you who have experience with Microsoft SQL Server are not as affected by this case sensitivity issue simply because, as you know, something like Microsoft SQL Server is a Windows-based RDBMS, and as we know, I'm quite sure you know, Windows has never historically been a case-sensitive operating system. Now, with MySQL that runs both on Windows and Unix platforms, how does this play out? Well, I've drawn you some nice flowcharts here, and let's take a look at what we need to know for the exam as well as for your success as MySQL DBAs. Now then, at the database and table level, we're talking about case sensitivity manifesting itself at the host operating system level. Now you'll recall when you build out your tables, tables manifest themselves in the host file system. Tables create format files, .frm files, and then depending upon the storage engine in use, whether you're using MyISOM or InnoDB or CSV and so on, you'll have one or more additional files in your data directory in the host OS file system. And in Windows, as I just said, we're talking case insensitivity, Unix case sensitivity. For columns, indexes, and stored routines, we're talking case insensitivity regardless of host operating system. And this can be proved by logging into your MySQL terminal monitor and running, for instance, select statements against a table. You can refer to columns in that table using uppercase, lowercase, or mixed case. Doesn't matter a bit. And you'll find that the returns come back just however you need them or want them. On the other hand, and I'll show you this in the demonstration, when you refer to a table, let's say you do select star from world.city, if you're on a Unix box, case is absolutely going to matter if you have city uppercase C versus city table name lowercase c. Now the theme here that I want you to understand as far as a take-home message goes, this is real-world stuff, is consistency, especially if you're managing more than one MySQL server. Because if there's nothing more of a pain in the hinder as far as I'm personally concerned when you're managing multiple servers, especially if you're in a replication environment where you have different settings regarding case sensitivity on different servers. because you may very well have inconsistent results with your queries and your stored routines. Another point here before I bring up the money of this slide is column aliases are also case insensitive, which makes perfect sense. Therefore, when we're doing a select statement and pulling columns, an alias, you might recall, allows us to rename that column name in our output for easier reading. Now, how can we enforce or create consistency with regard to our case sensitivity, especially regarding to tables? Because as you see here, the table is really going to cause us the problems when it comes to case sensitivity. Our columns and our column aliases, our stored routines and indexes are not affected by the case sensitivity. It's really only the databases and the tables. And like I said, really the table is where the meat and potatoes of this whole thing are. There's a really important directive that you need to be aware of, that you get the most bang for your buck setting in your MySQL option file, and that is lowercase table names. Depending upon how you set this directive, it can, and this is of course most effective on Nix. Windows is case insensitive anyway, so your select star against city, uppercase C or lowercase c isn't going to amount to a hill of beans either way on Windows. But certainly on a Nix box, depending upon how you set lowercase table names, whether it's 0, 1, 2, etc., there's a few different values, and I'll show you this in our upcoming demo. This can make a world of difference as far as how your case is evaluated for those table names. Keep that in mind, friends. Working with qualified names. As we said earlier in this nugget, a qualified name is either all or part of an identifier in a MySQL database. Now, I know a lot of CBT Nuggets customers come from a Microsoft background. Therefore, I always like to throw in transitional information. For instance, stuff from Microsoft SQL Server to, in this case, MySQL. Those of you who are expert with SQL Server know that a fully qualified name would go something like this: server name dot database name dot schema name, and then finally dot object, where the object refers to a table, a function, a stored procedure, etc., etc., etc. In MySQL, things are a lot simpler than that. Here in MySQL, qualified names are much simpler. We have traditionally database dot table. Now you can take it one more level out if you want to, database dot table dot column. Traditionally, you'll notice that servers are not part of qualified names. A little bit later in this training, we're going to talk about federated tables, and there we'll get into connection strings where we're connecting or pipelining between two MySQL servers. And you'll notice that there is in fact a differentiation between server syntax, that the server is actually part of the user connection string and not part of the object qualified name proper. Now, when do we need to fully qualify a name? Let's look at code sample 1. Here we're saying select star from world.city. Now, as long as you do have a database named world in your instance, and there's a table named city in the world database, this select statement will work all day long. If we have, for instance, used the use keyword to attach ourselves or shift our context to a particular database, then we do not have to prepend the database name to the table name. So, for instance, if we were logged into MySQL client and we issued use world, that is a great advantage to us as database administrators or database users because it lifts that qualification requirement. Really, the whole notion with qualified names is to reduce confusion on the part of the MySQL parser. In fact, I like to look at qualified names in relational database systems in the same way that you would look at qualified names in domain name system or DNS. If you've done server administration, you know that DNS is a way to take human readable or human understandable names and map those to IP addresses so you can resolve server or host names using those friendly names rather than numbers. And the way DNS works is it's a hierarchical naming system. So I might be on a server called SV1, And I can ping SV1 without having to fully qualify that name, sv1.nuggetlab.com, so long as my machine understands the rest of that DNS structure. Similarly, as long as MySQL, your server in question, understands the rest of the qualified naming structure of the database object in question, the identifier in question, you don't have to worry about qualification. Now, if we did not use the world database and we were just in MySQL client and we ran a select star from city, then we're going to run into some problems because MySQL parser is going to essentially say, all right, what database are you trying to hit? You see what I'm saying? Now I'm getting a little bit ahead of myself. Let's just take these code samples one at a time. Let's look at code sample 2. Code sample 2 is basically showing us what we described a minute or so ago, where if we use the use keyword, we can shift our database to a particular context, and then we can select against a table without prepending the database name, and that query happens just fine. Another way we can go is to optionally quote our identifiers. Now you notice that these first two queries went through just fine without quotes. As I've already taught you, the only time you really need to worry about the quoted identifier is if you're going to define some funky column name that might use, say, a reserved keyword, or in the case where it's a little bit in the gray area where you think that either a person or MySQL parser might get confused, or there's some ambiguity inherent with that word. Otherwise, you really don't need to worry about it. But it's always fine. The general best practice is, when in doubt, it never hurts to quote your identifiers. MySQL parser will never bark at you if you use the backtick. Just you have to use them correctly. I mean, look here. Select star from world.city. You have to use your backticks appropriately. In other words, backtick world, backtick dot, backtick city, backtick. So each object, each identifier is enclosed with the backticks. That will certainly hang up some newcomers to MySQL administration. For instance, if you were to try select star from world.city and enclose the entire qualified name in a single set of backticks, you're going to get a problem here. Table world.world.city doesn't exist. You see what happened? Now, this assumes, just judging from this output, the fact that MySQL parser prepended world to this, that we're still using the world database. So if you don't qualify a name and you are using a database, then MySQL will automatically prepend any table that you use in a query with the database that's being used. And it assumes that this is the table name, that this is what's called a string literal. And of course, you don't have a table called world.city, or at least we must not in this example, because MySQL parser is returning error 1146, basically object not found. In our demonstration, we're going to create a couple objects using reserved words and look at the errors that come up, and we'll look at how we can use quoted identifiers to override those problems. We'll also look at case sensitivity and table names. Second part of this demo is we'll do a little bit of working with qualified names, and we'll basically take some of those examples that I just showed you in the previous whiteboard, and I'll show you how those work in a live production environment. Let's get to work. Okay, let's get this demo up and running. We are on an Ubuntu Linux machine named LinNugget01. It's completely stock, freshly installed, connected to the internet, and I've installed MySQL 5.1 as well as the world sample database. Why don't we fire up a terminal shell and get logged in. I'm going to log in as root, and we'll just do the traditional show databases to see what we have there. Just as I promised, we have, I guess we have not just the world sample database, but the Sequila. Now, if you haven't watched my other nuggets, and if you're not aware of this, The World Sample Database is what the MySQL Training and Certification Group uses for all of their training and all of their examples. If you've purchased any of the MySQL Press books, any of the Cert Prep guides, all of their examples come from World. And frankly, as I go through this training, all of my examples will be focused on World predominantly, and I'll also pull some examples from the Sequila Sample Database. Both of these are freely available. You can easily download those from mysql.com. You'll just want to hit up the mysql.com documentation site and go to their example database section. They're completely free and they're excellent. So therefore, you can follow along with exactly what I'm doing as I go through these demos. Now then, let's start off by using qualified names and case sensitivity. If we just do a show tables from World, now I'm not using any database yet, am I? We can see that we've got city, country, and country language. Now remember what we've learned already about NICS and case sensitivity. We know that since these tables are showing up in title case with capital C's, we should have to specify the correct case whenever we run queries against these tables. Therefore, if I run a select star from city, well, first of all, is this query going to work? Select star from city, lowercase c. Yes or no? What do you think? Well, let's try. No database selected. How can we fix this? I can think of at least two ways. One way is we can say from world.city. Here we're qualifying or telling MySQL parser which database the city table comes from. Now, is this going to work? Let's try. Table world.city doesn't exist. Now, I'm being overly simplistic here. I'm not trying to insult your intelligence. I'm just taking it a step at a time to prove and to show these concepts in living color. As an instructor, it's important to build our concepts and build on what we already know and take theory and put it into practice. So let me use the up arrow to bring back the previous command from the buffer. Now remember, database names are not necessarily case sensitive. It depends on the operating system. I defined world with lowercase w, so the world is fine with the lowercase w. However, the city is not. So if we do this, and I'm going to use the limit keyword because city has many rows and I don't want to sit here twiddling my thumbs as all of those rows come back, so I'm just going to specify a cap on the number of rows that come back. Let's see what happens. That worked like a charm, didn't it? So this proves a couple things. This proves, number one, case sensitivity for tables is in fact a huge issue with NICS. And number two, we do have to keep track of qualified names. Now, if we use the use command and use the world database, we can then select star from city, capital C. I'm going to limit to 3 here because we're not concerned with the actual data, just that the query actually works. Another point to ponder is that the SQL keywords are not case sensitive, regardless of your situation. So if we up arrow, and then I'll come back over, and if we do something like this, we get the same response. So I just want to stretch our boundaries here and make sure we know what's going on. Now, can we retroactively change our environment on this server such that when we make comparisons in our select statement, and by comparisons I mean when we go to retrieve rows from our world database, from these tables, that the MySQL parser ignores the case of the table names? Well, we know that we can, remember? Let me bring up my browser here. We have the lowercase table names system variable. And this is a great mini introduction to a site I'll show you a lot over the course of this training, the MySQL Reference Manual. This is a site you should become intimately familiar with if you're not already. It's your compendium, and it's fully downloadable, by the way. I like to go online to make sure I'm getting the most recent information, and also community folks like you and me can make comments and add extensions to what the MySQL team has in this documentation. So really, in my opinion, the web is the best source for the RefMan. Regardless, the lowercase table names variable, it's important to understand how they give the information here. The command line format, the dash dash, is where you would pass this on the command line if you were starting up the MySQL daemon interactively. However, I like to work as much as possible from the option file, so you can set the parameter at server startup such that every time the server starts up, the variable kicks in. And when you do that, the config file format is what you use. You don't use the dash dash, you just say lower underscore case underscore table underscore names equal, and then it takes a value. The default is 0, which means that the operating system takes care of table sensitivity, and we know that with Nix, they are case sensitive. What we're interested in is a value of 1. If set to 1, table names are stored in lowercase on disk, and table name comparisons are not case sensitive. We see that the variable scope is global, so it affects the entire server and all users. It's a pretty big change. So the only caveat I would say is certainly don't just in a production environment make this change without notifying your team, for heaven's sake, or your user base. Here in a lab environment, it's fine. Now that we understand how lowercase table names works, let's just make the change in the option file, and I'll show you how that particular phase works. Minimize our browser, and the thing we need to do is set this option in our option file. And to do this in Linux, I prefer to go the command line or terminal shell route. So from a non-administrative or standard shell prompt, I would do sudo pico, that just happens to be my favorite text editor, etc mysql my.cnf. Now, depending upon how you've installed MySQL on your Linux box, the location of your configuration file or option file may differ a little bit. I did use a package installation on this Ubuntu machine, so mine is in this particular location. Now then, in your option file, you'll scroll down past the client section into the MySQLD section, and I've already added the option here. You'll just find an uncommented line and add lower underscore case underscore table underscore names equals, and then whatever value you want. In this case, we'd probably want 1. In Pico, you can save your changes by using Control-O. We're going to write over the existing file, Control-X to leave. Now, when you make a change to the MySQLD portion of your option file, you have to restart the MySQL daemon or the MySQLD executable. The specific procedure for reloading MySQLD differs just slightly depending upon how you've installed MySQL under Nix. Under Windows, it's a snap. net stop MySQL, net start MySQL. On an Ubuntu box like I have here, the bootstrapper is under etc init.d, and then we could just say mysqld space restart, and then you're good to go. After the restart, there may be some additional work required to get your tables fully operational. Best practice, take care of setting the lowercase table names variable before you create your tables. That's definitely best practice. Alrighty, let's get back into MySQL. We'll connect up to World, and I'll just briefly show you how we can use identifiers, quoted identifiers, and reserved words if we need to. Now, we've used the World database. We can show tables if we want to. Let's create a table called test, and this is just going to have a single column, and this column's going to be called order. Now, do you see what the problem is? Order is a clause that we use in the select statement, isn't it? It's used for sorting, inverse sorting or ascending sorting. And let's just make this int, not null, and we'll throw in a unique constraint on it. Soon as we throw that batch to the wind, we get an error. It tells us that line 2, which is our order line, is the problem. Well, of course, we know what the problem is. Order is a reserved word. We can go online and search that error if we want to, but we actually know what the deal is. Now, if we quote the identifier, we're explicitly telling MySQL, hey, we want to use the word order. I mean, after all, customers, orders. I mean, one way to do it would simply to use ORD, order num. I mean, you don't have to use the word order, for heaven's sake. We'll bring back our definition, come back to order, throw in our quoted identifier, our backticks, and we're fine, huh? Show tables, and you notice that our test table came back just fine. So if we do a show create table test. The order comes back just fine. And just for grins, actually, let's do a show create table city. And you notice that the formal definition of these tables in MySQL gives us the backtick identifier anyway. Understanding identifiers review. In this nugget, we formally defined what an identifier is and what an object is. I hope you're clear on that. An identifier is simply a method of identifying or locating a database object in MySQL. And we learned that we can do that either by creating or referring to that object in an unquoted fashion, or we can use the backtick or potentially even the double tick to mark those identifiers. We then spent time using qualified object names, understanding how MySQL interprets or parses qualified versus unqualified object names. Oh, and I almost forgot. We threw in some issues of case sensitivity, which is a particularly important issue with MySQL due to its multi-operating system, multi-platform nature. I hope that this has been informative for you, and I'd like to thank you for viewing.